Hi, this is Austin with assignment 8. This first one is the color fog, the color light fog. So you can see that it's done in a CBuffer now. And I'll come down here to the bottom and show you that the actual code is using those CBuffer values rather than the preset ones from earlier. And if I come in here to the DXApp file, I can find the fog data just passed in with the same values as in the previous HLSL file. So I have the gray version and then the blue version, which is the one I'm using. So if you'll look here in the shader, you can see also that I have the fog data, send fog data function, and a separate buffer for all of that, and the C++. It's really quite simple because all I'm doing is just taking those values, plugging them into the data, and sending it. And I will run it. So it looks pretty much the same as the original. And as I zoom out, everything will gradually be clipped away by the fog, except for the yellow square, just like the original one. So you can see that it still works. So the texture light is the same basic process. Once again, I will have a CBuffer here with the fog data right here. And at the very bottom, you will see that I'm using those values to compute the new texture. And I rearranged the lit color a bit so that I could still use the sampler and then apply the interpolation and then return that, which is a little different than the color light version, which I just left as is, where it would do the lerp and then return that right away. Again, the DXApp will call the fog function right here. Again, same deal. And the shader texture has the same functions and buffers as with the light. And I will run this. So I just textured everything so that you could see it was working, again, except for the yellow box. So that's why everything is a really good looking box model that doesn't actually line up. But again, I will pull away and you can see that the fog still works properly. The background's already fading out, and now the cube in the middle will start fading out as well. And there it all goes. I won't go all the way out. That should be enough to demonstrate that that works. So now I will look at the mirror function. So step 1 is the same, except I'm initializing two extra. I'm initializing a color light and a texture light in addition to everything else, and setting the point lights there. So most of this is all just the same process, just with a lot more juggling of shaders. Like you can see already I had to reset the shader color for the mirror, switch back over to the shader color light for the plane, which is what I'm using to demonstrate that. And then the cube in the middle, I used the texture light shader, so I switched to that. And then I guess I can take a brief look at the math here. All I really did was multiply the position by the reflection matrix, and that gives you the right results for the spotlight. And other than that, it's all the same process. So the important thing is for step 4, switch back to the original shader that you want to use to create the mirror, and do it again. And then step 5, because this is using the same shader as the mirror, I don't need to change it, but if I weren't, I would need to set it again here, and then send all of that data. So that should be, oh, and I am deleting it, but that's not much to note. And I will run it here so that you can see both results. Actually, while I'm loading it, I'll mention that I did slightly adjust the bottom plane, because otherwise it would clip into the mirror space. It needs to end before the mirror, otherwise they overlap, and the plane outside the mirror overrides the plane inside the mirror, and it just looks weird. I'll explain a little more in detail once it actually loads. Okay, so here's my mirror, and you can see my rather faint but still present spotlight. You can see that as it turns around, this side of the block will slowly become less illuminated, and in the mirror, those sides of the blocks that I can't see from this angle will become more illuminated over time. And you can also see the outline of the spotlight on the ground, going in the right direction on both sides. And now it'll start circling around again, and once again, this side will stop becoming illuminated, and this side will start becoming illuminated. So there's my texture, and then the ground is the is the light shader. So yeah, from this angle, originally when it was a diagonal plane, the sides of this plane would actually come into the mirror from like here. And that part would become really glowy because it was still computing based on this light rather than the light inside the mirror. So what I ended up doing was realigning the plane so that it was a straight and that it wouldn't go behind the, or it would barely at least go behind the wall of the mirror. And I'm probably not going to use a mirror in my final project, so I did not implement the entire class, but I did want to at least lay out like a .h file of what I would probably use. So I'd keep the actual flat plane that is used to render the mirror, the matrix for reflection, and also the actual matrix of the mirror itself. So this is just the creation stuff from the initialize function, where you'd pass in the device, the size, the H and vrep, use that to generate the mirror, and then generate the matrix based on the dimensions of the flat plane. The render is specifically for rendering the mirror itself. So you just pass in the shader you're using and the devcon. Ideally, you'd be storing the devcon so you didn't have to pass it in every time, but I wanted to leave this in here to demonstrate that this is one place you would need it. So here I have various step 3. The way that I was thinking of doing it would be have a different function for each like the color light, the texture light, the regular color and texture, and pass in all the same stuff like the cameras, and probably not the cameras actually, because you only need to set those once, but you'd have to pass in the light parameters for each time you wanted to update that case. Yeah, you could update the lights each frame if you wanted to. It's basically just the call in the in here, wherever I would set point light parameters in the mirror itself. Let's see if I can find it. So take all these, essentially, or all these rather, where is it? Yeah, here we are. The ones that are actually different inside the mirror, and put those in a separate function within the mirror class. So looking back at this, what I do next is I have a conclude function that's specifically for the last couple steps in step 3, where you wrap up these. And then could bundle those into second render, but I had them separate for now. And then the second render is just the one that actually applies the tint to the mirror.